Okay, last section in chapter 3. It's arithmetic. If you say arithmetic, it's no big deal. Sequences as a linear function. It says a sequence is a set of numbers called the blank of a sequence in a specific order. So the terms. So if you look down here, these are sequences. They're terms that are right in a row. An arithmetic sequence is a numerical pattern that increases or decreases at a constant rate called the common difference. Okay, so an example would be like 2, we're going to add 2 more. 4, add 2 more. 6, add 2 more. 8. That's a common difference between them, ... That's an ellipsis. A non-example would be 2 multiplied by 2 is 4, multiplied by 2 is 8, multiplied by 2 is 16. Okay, that is a sequence. It's just not an arithmetic one. Okay, it says the 3 dots used with the sequence is called an ellipsis. The ellipsis indicates that there are more terms in the sequence that are not listed. So I really should go comma ... meaning there's more to come. Example 1. Determine whether each sequence is an arithmetic sequence and explain. So, am I adding or subtracting the same thing every time? 3, 3, 3, yes. So you have to make sure for all of them they try to trick you. So yes, the common difference is a positive 3. Okay, the next term, we're multiplying by 2, it looks like. That's what I just had. Well, if you try to look, the common difference is 2. Then the common difference is 4. Then the common difference is 8. So no. No does not have, doesn't exist, if you just want to write that. Next one, if you're like, how would I figure that out? Say you couldn't think about it in your head. We'll just do 11 minus the 9.5. Oh, that's 1.5. Okay. Is this 1.5? Yes. Is this adding 1.5? Yes. So yes, common difference is 1.5. It says you can use a common difference of an arithmetic sequence to find the next term. So if they want you to find the next 3 terms of the sequence, this is what you need to do. Here you can see, okay, I add 6, I add 6, I add 6. So then if I add 6 again, I'm going to get, no, not 30. Why am I doing that? I'm going to get 32. I add 6 again, I'm going to get 38. I add 6. Yeah, it was 30. I'm sorry. Excuse me. Okay. I add 6 again. It's 30. Sorry. We're at the end of the school day here, and I'm losing my marbles. 36. 42. Does that make sense? All right. Here, you could tell by you're adding a third, and you're adding a third, and you're adding a third. If you add a third again, you have 2/3. And if you add a third again, you have 3/3, which is the number 4. So it's in that pattern. And then 4 1/3. Here, this one, your common difference here is a -3. You're adding a -3 every time. So if you add a -3 to 3, you get 0, and then -3, and then -6. So all it is patterns. You might have remembered that from like first or second grade. We started to learn about patterns and define the next sequences. Okay, sequences actually can be written as equations. So the nth term of an arithmetic sequence, we say the nth term or whatever term you're trying to find, we just call it the nth. You could have called it the nth, the jth term. They're saying whatever term you're finding. This is whatever term you're finding. Okay, where A1 is your first term. The common difference is D. This is the equation to find that. Okay, so it says write an equation. Whoopsies. Write an equation for the nth term of the sequence and then find the 12th term. So whatever term I'm trying to find, you need to write your first term, you need to write your common difference, and then just n minus 1. So whatever term I'm trying to find, you take your first term, which is 25 here, your common difference every time, which is subtracting 6, and then n minus 1. So you can leave it like that, but we like to clean it up by distributing that -6 and making it +6, so that a sub n, we say sub for subscript, a sub n, okay, whatever term you're trying to find, -6n plus 31. So this was term 1, this is term 2, this is term 3, this is term 4. They use a for some reason instead of t. I don't know why, but some textbooks have t, some have a, okay? It says write the equation for the nth term. It says now find the 12th term. So the term I want to find is a12. So -6 times 12 plus 31. What's that going to equal? Well, -6 times 12 is -72. And then if I add a 31, I get -41. Okay, I get -41. They have a graph here so that if you look, your first term is 25. You could graph it and see what that looks like. Your second term, 2, is 19. Your third term is 13, something like this. And then your fourth term is 7, something like this. So notice it goes in a line. Arithmetic sequences are linear, and that's why you're learning about them, because Algebra 1 is all about linear relationships and graphs. Same thing here. My first term is a -7. My second term is a -4. My third term is a -1. My fourth term is the number 2. So it goes in a line. Okay, so, sorry. So if I'm trying to find an equation, here's the formula. Okay, here's my formula. I write down my first term, which is -7. Then I write the common difference, which here you're adding 3 and -1, because n can be different every time. So if we clean it up, a formula for this sequence is now this. So if I wanted to find the 12th term, instead of going, all right, sorry, this is reminding me to get my taxes. Instead of adding 3 every single time, 12 times, you could just say, plug it in here and say, okay, what would that 12th term be? And it should be 26. Well, I like to find out, all right? So here we have our first term, our second term, our third term, our fourth term. So 2 plus 3, fifth term, sixth term, seventh term, eighth term, ninth term, 10th, 11th, 12th, 26, 26, okay? It does the same thing for you. It's a shortcut. All right, flip to the back. It says Kaya, I think, has $520 in a savings account. After 1 month, she has $580. Okay, so 525. She has $580 after a month. The next month it's $635. The third month it's $690. Write a function to represent this arithmetic sequence. Well, we just wrote down the formula. We said a sub n equals your first term by however many common differences you're adding, n minus 1. It says write a function to represent the arithmetic sequence. How much will Kaya have saved after a year? Okay, so a sub 12. Okay, so she starts out with 525. So 525, and then she has 580. So we're going to take 580 minus 525. That's $55. So that's going to be your common difference. Okay, so her common difference is 55 and minus 1. Her first term is 525. Okay, and we're at a sub n. So 525 plus 55n minus 55, a sub n is 55n, 525 minus 55 is 470. So after 12 months, what do we get? We got 55 times 12, which is 660 plus 470, which is a total of 1130. Okay. It says, how much will she have saved after a year? Okay, well, she started at 525 and now she has 1130. That's $605. All right. In a theater is 20 seats in the first row, 22 in the second row, 24th in the third row, and so on and so forth for 25 rows. How many seats are in the last row? Okay, so for 25 rows is what they want to know. So your term that you're trying to find is your first term plus your common difference n minus 1 times. So if you're trying to find the 25th term, you're going to take that first 20 and you're going to add 2. How many times? 25 minus 1 times. So 20 plus 2 times 24 is 20 plus 48 equals 68. You're going to have 68 seats. Okay, and lastly, it says the price to send a large envelope first class mail is 88 cents for the first ounce and 17 cents for each additional ounce. The table below shows a cost for weights up to 5 ounces. How much should a large envelope weigh that costs $2.07 to send? So we know this is our formula. We know that our common difference is 17 cents every single time. We know that our output is 207. Okay. We know the initial is 88 cents. Okay. We don't know what number it is. It says how much should a large envelope weigh? So that's our input. So we could just solve the equation like normal. Oh, it said 17 cents. Whoops. So 0.17, 0.17. So if I add 0.17 to both sides, 224 8 ounces. And that's it.